Welcome to UGC Net and GATE Computer Science students. In today's topic, I will be discussing software engineering towards to prepare UGC Net June 2020 examination. So here you can reach me for any query. Here software engineering have only limited problems, so usually they will be asking cost estimation technique, and then effort of making software and development time, and these are the major problematic question they used to ask. And here the syllabus is starting with software process model, software requirement, software design, software quality, estimation and scheduling of software project. And usually they even ask question with the problems as cost with the COCOMO model and estimation model. And then here software configuration management, software testing, and these are the syllabus, and you supposed to know all theory, then only you can score good mark from software engineering. So here I'll be directly going with some important as well as problematic questions. Here, according to ISO 9126 standard quality model, match the attribute given in list 1 with their definition of with list 2. Okay, so here what is functionality? What is here functionality is nothing but the characteristics related with the achievement of purpose. What purpose for which you are making software, and its characteristics supposed to worked out in the functionality. So now next one is what is reliability. So reliability in the sense what, and for stipulated time it has to reach and keep their performance. So that is capability of software to maintain performance of software. Okay, and that is said to be reliability. What is efficiency? Efficiency is what, and whatever the amount of resources you are put for making the software, and for that its performance supposed to achieved 100% kind maximum. Okay, that is a dB efficiency. So here relation between level of performance and amount of resources, that is a dB efficiency. What is maintainability? Okay, maintainability is what? Okay, and so here at any situation we will be getting error, and once rectified it will be it is improved. Okay, that is said to be maintainability, and for that effort need to make for improvement. Okay, so that is usually in software cost maximum 70% we are allocating for maintaining the software for some duration. Okay, so next question is match the agile process model with the task performed during the model. Okay, and here we know agile process is one of the software development model, latest model, and which using no duration for each and every phase. Okay, it will take any percentage of duration for any kind of process activity in this model. Okay, so here something terminology called Scrum. Okay, what is Scrum? Okay, and it is nothing but a sprint backlog present in such a model, and then adaptive software development. So actually agile is adaptive software development, so it is nothing but what, time box release plan. Okay, so it is flexible. And extreme programming, what is that? Extreme programming, which is nothing but sorry, actually Scrum is CRC card, and your extreme programming is nothing but uh, sprint backlog. Okay, so here next one is what is called future driven development. Future driven development is what? And so as per action we will be getting result, and then we are define the objective, and that is said to be future driven development. Okay, next question is and dash chart is a project schedule representation that present project plan as direct graph. Okay, dash in the and in the sense word start with a. Here activity chart is a project schedule representation that present project plan as direct graph. Then the critical path is the but the shortest or longest is nothing but longest, and longest sequence of what is called it is not independent task, it is dependent task, and it's defined project duration. Okay, so now activity chart define the project duration. Okay, next one is consider the following models: Mamdani model, Takaki Sukino Kong model, Costco additive model. Which of following option contain example of additive rule model? Okay, actually this Mamdani fuzzy inference model present here, that is Mamdani. So here and rest of the M2 and M3 are said to be even Suguno fuzzy inference system, so it is coming under what is called additive rule model, and pure additive rule model is that what is called third one, M3 Costco standard additive model. Okay, and next question is match list 1 with list 2 software process model, and then list 2 is a software system. So here what are the software system for which kind of software development model used? Okay, so here basic model is waterfall model, and it is classical model also. Okay, and next one is incremental development, prototyping, and rapid application development. So here what are the type of software for which is adapting very quickly, and here what is the waterfall model is automate the manual system of student requirements in the school. That is the best project for waterfall, because waterfall is following one phase completed, then it goes to next phase. Student detail also like that. Okay, for example, if you want to achieve and we know database of student, then we need to keep updating all the details, so then only we can make the software. Then increment development. What is this increment development? Is nothing but so e-business start with only basic functionality. Usually every time we are updating improving software. So for that best example is e-business. We will be starting with simple functionality, later we are add up some more functionality, keep on. Okay, so then what is prototyping? So actually for prototyping model, software user never need to know some even basic information. Without that he will easily able to work out such a project. Okay, for example example here are inventory management, like that. Okay, and here so what is the option given here is nothing but virtual reality system assimilating vehicle navigation in highway. Okay, and then finally what is called rapid application development, RAD, for that inventory control system or supermarket to develop an highway. Okay, and then okay, next one is match the UML diagram list with appropriate description. Okay, what for? Okay, we have set up diagram like state diagram. What is state diagram? So your state diagram is nothing but used to describe dynamic behavior of object and could also used to describe the entire system behavior. And next one is use case diagram. Use case diagram is describe how external entity, people, device interact with the system. Okay, and class diagram. Okay, class diagram is what used to describe static or structural views of system. Okay, and finally activity diagram. Activity diagram used to show the flow of business process. Okay, step by step. Okay, and next one is problematic questions. Okay, here legacy software system has 940 modules. Latest release require that 90% of these modules be changed. In addition, 40 new modules were added and 12 old model were removed. Compute the software maturity index for the system. Okay, and index should be from 0 to 1. And okay, so we know that there are 940 module present in software system which been already developed. Okay, here it need 90% of this module to be changed. Okay, while doing that, and we also do two more thing, 90 new model you have to add. So from this 90% is what? Okay, 90% is nothing but almost some 800 and plus. Okay, will be there. Okay, and 90 of this model alone changed. Okay, not 90%. Then for 40 new modules you want to add. Also we want to remove 12 modules. Okay, so now what happen is here okay, so what he has to do, the number of module in the current release, then we have standard formula for this, that is software maturity index is nothing but mt minus fc plus fa plus fd divided by mt. Okay, so mt is nothing but number of modules present there, right? Okay, so what happened, 940 minus 90 module to be changed, so that is fc. Okay, fe. Okay, adding module here is new module adding is 40 and removing module is nothing but 12. Okay, and divided by 940 again, so we will be getting 0.49. Okay. Okay, so now next question is what? Assume the following regarding development of software system P, and estimate lines of code P equal to 33480 lines of code. Average productivity for system model P is nothing but 620 lines of code per person month, which means per engineer able to make 620 lines of code for a month. Number of software developer here is 6. Okay, now for a month how many lines of code they can develop is what? 6 into 620. Okay, now average salary of software developer is 50,000 per month. If E, D and C are estimate development effort in person month, estimate development time and estimate development cost respectively, then what is actual EDC? Okay, so now actually average productivity is what? Per person 620, number of developers 6, average salary. So now what is that? Development effort we want to put what? 3348 total number of lines 480 divided by 620. Okay, now 54 person month. Totally, if suppose single person working, then he take 54 month. Okay, so then development time, actually 6 people there, how much time they take is 54 person per person month present there, right, divided by 6, which is nothing but 9 month totally they need. Okay, the cost is what? Okay, which is nothing but how many month into how many person into salary of person. Okay, so this 27 lakh. Okay, very simple formula related question. Okay, so next one is match the following software engineering. Okay, here product complexity, structure, system analysis, coupling and cohesion, symbolic execution. Okay, so here product complex is nothing but software cost estimation technique, and then structure system analysis is nothing but software requirement definition, and then coupling and cohesion can be used where? Okay, so can be used in software design, and then finally symbolic execution can be used in validation technique. Okay, next is another problematic testing. A software system crashes 20 times in the year 2017, and for each crash it took 2 minutes to restart. Okay, approximately what is the software availability in that year? Okay, so now they are saying that 20 times for that particular year the crash was happened. Then in order to reboot the system, it take every time 2 minutes. Then what is the total time it take for 20 time is nothing but 40 minutes, right? Okay, so now how to, we know that for a year 365 days there. Okay, so now we want to multiply what? So 2 minutes 20 times. Then what is that? Each day has how many minutes? First you want to multiply. So because we need to know how long it will be available without any error is in minutes. So first you want to multiply 365 into 1 day. How many minutes is nothing but 1440. Okay, so now totally this minutes there, and we know how much minutes we want to reboot it, that is 40 minutes. Okay, because 20 time failure happened. Now software availability is nothing but with error divided by total duration in minutes. Okay, so it is almost 99.9924. okay, and next one is capability maturity model, CMM. So we have 5 types, CMM 1, 2, 3, 4, 5, right? Initial, repeatable, defined, managed, optimizing. These are the order. Okay, what is initial? Okay, initial is nothing but what? Here there may not exist plan or maybe abandon. Okay, this is initially developed model, and then what is called repeatable. Okay, repeatable, there is a plan and people stick to it. Okay, so they frame the rule, and as per plan we want to follow. Okay, and next one is what is called defined. Okay, defined is nothing but plan for project come for template. So third model only they develop template. Okay, and then managed is nothing but plan use process that can be measured quantitatively. Measured plan happen in fourth, managed. And finally what is optimized process improved quantitatively and continually. Okay, and next one is a signal process software expected to operate for 91.25 day after repair, and mean software repair time expected to 5 minutes. Then availability of software. Okay, and they given how much duration in days, and you want to measure it. Okay, so suppose they are saying that it is 91.25 days in 91 days, then what is that? It is nothing but 6 hour. 0.25 in a day is nothing but 6 hour, because 24 hour is 1 day, half day is nothing but 0.5, which is nothing but 12 hours. Here how to measure is 91 day and 6 hours. And divided by total, here 5 minutes you want to add there. So along with this total days, so 91.2 y divided by, after adding 5 minutes with this particular detail, so it is 99.996. Okay, next one is a simple stand-alone software is utility is to be developed in C programming by team of software expert for computer running Linux, and overall size of software estimated to be 20,000 lines of code. Considering a comma b factor is 2.4 comma 1.05, multiplicative and exponential factor for basic COCOMO effect estimation equation, and c comma d is nothing but this value for as multiplicative and exponential factor for basic development type. And here approximately how long does software project take to complete. And it's very simple. We know that basic COCOMO model effort can be calculated with factor a into kilo lines of code power b. So here they mention all the values and we want to directly substitute, but only thing is for 20 power 1.05 you want to manage. So this 58.76, and d is development type, which is c into e power d. And we already know this index value, c equal to 0.5, d equal to 0.38, then it is nothing but 2.5 into 58.76 power 0.38. So now for this almost you want to take cube root. And totally it is nothing but what is called 11.52. So months we want to spend to develop such a software. With this I stop here. I will be discussing rest of the probability question in next part. Thank you.